What's going on, everyone? This is Nexus Maven. Today we'll have a hands-on lab for beginners. It is Cisco Nexus basic configuration. Here you're looking at a Cisco Nexus 9504 was created in 2008 at a switchboard data center. We deployed this hands-on content for those who have touched the Catalyst iOS CLI but have never touched the Nexus OS. So if you have experience with iOS, you will be able to smoothly proceed with NSOS configuration. I hope you take this opportunity to experience the differences between iOS and the Nexus OS. In this hands-on lab, I will create an L2 and L3 configuration and VPC virtual port channel scenario, which is a typical Nexus feature. The L2 L3 setup can be completed in about 1.5 to 2 hours, and VPC included can be set up like in 3 hours. So 2 leaves and 2 spine units that are configured via CLI from a web host connected to my CSR1. So in this lab is to check the communication between a web host connected to CSR1 to the XSI and a server connected to leaf. Configuration from console at first login and management interface MGMT0 configuration has already been done, and the procedure is also included. So the sample configuration will reference in the end of the lab. So first, the initial setup, you will know how to configure the settings when you first log in and how to configure the management interface. I'll take a look. Here is a management interface located in the chassis control supervisor, to supervisor in 9500, and in there you can console in and configure your management to VIF. So let's log on to my spine 1, and I configured my host name as you typically would do in iOS. Show run interface MGMT0 is what I have configured for VIF and IP for management. If necessary, you will configure some VIF routing. You have to configure VIF contact management. Mostly it will create it already, and you will need a IP static route. I don't need it because I could just log on from it in the same subnet. Okay, there's a dedicated ports in the Nexus. I want to show you the ports to here. This port is gonna be your management port, okay, and this port is your console. Only the MGMT0 belongs to the VIF management. Okay. No, that's boring stuff for the initial setup. I will do some checkup. Show module. Here I can see my virtual appliance module 9000V is I could do things like question mark on the fly. If it is already familiar to you, I could do some interesting things like a feature into VLAN is how you enable some of VLAN configures, and if you show run, you can just anywhere you can do a show command anywhere you want in Nexus, and this is how you enter the interface Ethernet 1/1. If you want to enter multiple, you can do 1-10 to just enter that range of interface. So let's do some L2. We're gonna create a VLAN and VLAN 10 and 20, and we'll configure our trunk. The trunk is the interface between spine and a leaf. We'll have to assign this to a VLAN 10 and 20, and we'll set the trunk on the interface connecting to the leaf server. Here we'll assign a VLAN to the server and server. Also, we wanted to create a port channel. We're going to set up port channel 500, and member will be in Ethernet 1 and 2. Ethernet 1 and 2. And we like to make some priority in STP spanning tree. The spine 1 will become root in spanning tree, and we're going to set a priority for spine 1 to do so. And I want to see the interface blocked. It's blocked and blocked interface like this. Also, you will see the port type. The port type set up correctly for the interface. So let's begin. What I have to do is the VLAN 10 and 20 on my leaf. You can create it like this with a comma, and let's log on to leaf 2, VLAN 10 and 20, easy peasy, show VLAN 10 and 20 created, go log on to spine 1, VLAN 10, 20, spine 2, VLAN 10, 20, then here, show VLAN, see the VLAN credits, 10 and 20. Now take a look at the diagram, 1/3, 1/4, 1/3, 1/4, 1/3, 1/4 are inter switch interfaces. That's what we're gonna do. We're gonna do to enter this interface 1/3 and 4. We want to say this will be the trunk. So let's say switch mode trunk, switch mode trunk. Alright, switch trunk, allow VLAN 10 and 20. Let's show route interface Ethernet 1/3, 1/4. That's how we have to configure between interface between the leaves and spines. So same thing, leaf 2, interface Ethernet 1/3/4. Paste all that. We'll have to configure. Same thing. Interface VLAN. Interface E134. We want to make sure they're the trunk. And no shut. Log on to my spine 2, interface EU34, switch mode trunk, switch trunk, allow VLAN 10 and 20, no shut. Okay. Also, no shut on the leaves, no shut. Then we have to configure something for my server side. To my server side, I have Ethernet 5 and 6. 5 and 6. So Ethernet on the leaf 1, we have to use the side of VLAN to allow the trunk VLAN. Ethernet we're going to allow 20, and Ethernet 6 we'll have to allow VLAN 10. And on the leaf 2, because it's gonna be a trunk, so we'll have to allow 20. This 10 to the server 3. So just let's do it. Interface Ethernet 1/5 to EXSI 1, which includes server 1 and server 2. So what we have to do is no shut, switch port, switch mode trunk, switch mode trunk, and switch trunk will allow the VLAN 20. Interface Ethernet 6 that goes to server 3 will allow VLAN 10. Log into my leaf 2, Ethernet 1/5, allow VLAN 20. Here, to 6 server 3 will allow VLAN 10. Now we configure the trunk between the server, leaf servers. We'll have to create another thing, it's called port channel. Take a look at the diagram here. The port channel is happening in the spine. We have to use the protocol called LACP. We're going to use it for the port channel, so a feature of Nexus OS in intro function will be enabled. So let's log on to the spine. We'll have to configure this port channel first. The first thing we're going to enable feature LACP. And we're going to enter interface Ethernet 1/1.2. That's 1 and 2 interface. First thing we're going to do, we're going to shut down, switch port mode trunk. We'll allow trunk in between the spine 1 and spine 2. Switch port trunk will have to allow VLAN 10 and 20, and we'll say channel group 500 mode is active. 500, and we'll have to interface like port channel 500. We'll give a description. I'm saying is the link to spine 2. All right, so now let's go to my spine 2. Same thing, we're going to enable feature LACP, and also we have to configure the ports 1 and 2 for the port channel 500. Okay, now interface E112 no shot, switch port mode trunk, switch trunk, allow VLAN 10 and 20, channel group is 500, mode is active, and interface port channel will give a description is the link to spine 1. So then let's check the trunks for spine 1 and spine 2. So we have to do is show interface trunk, enter. Now I'm seeing is Ethernet 1, 2, 3, 4 are enabled, and a port channel for the VLAN 10 and 20. Same thing here in my spine 2, show interface trunk. Go down here, allow VLAN on the trunk 10 and 20. These all are 1, 2, 3, 4 are all allowed to 10 and 20. So it's very useful command, because I will notice if you be careful, I'm saying 10 and 30 instead in my Ethernet 3 and 4. So that's misconfiguration. We'll go to Ethernet 3 and 4, switch trunk, allow VLAN 10 and 20. Show again. Now it's correct. So you have to show it in order to double check. It's a very good way to examine your misconfigurations. For any error, you have to show it, and we want to show you another one too. We're going to check the port channel status of spine 1 and spine 2. We're going to show port channel summary. See the P port channel is showing SU, and make sure you will see SU because that switched and up. Also go to my spine 2, show port channel summary. I'm seeing SU also. Alright, so this part between the port channel is completed between the spine 1 and spine 2. Now let's take care of the leaf 1 and leaf 2 and their port channel 500. It's similar to what you have to configure on the port channel between the spines. Log on to leaf 1. Same thing, we will enable LASP for the feature. The ports will be 1, 2, 1 and 2. Interface is net 1/1, 2. No shut. Switch port mode trunk, switch port trunk, and allow VLAN 10 to 20, channel 500, mode active, Now enter the port channel 500. Description is a link to leaf 2. Go to leaf 2. Same feature, LACP. Interface Ethernet 1/1, 2. No shut. Switch port mode, trunk, switch trunk, allow VLAN 10 and 20, channel group 500, mode is active, interface, port channel 500, description, I'll give it to link to leaf 1. Now take a look at show interface trunk. Now we can see the allow trunk is happening. Okay, and well, one missing one is show run interface Ethernet 1/6 is not configured. Instead, I'm seeing E/5 is configured on leaf 2, so we're missing config. And also I'm seeing this configured around allow VLAN on E/5, so I have to change internet E/5, switch trunk, allow VLAN 20, right? It's VLAN 20, interface E/6, switch mode trunk, switch trunk, allow VLAN, that's 10. Alright, let's show interface trunk. Now 1, 2, 3, 4, we're allowing all VLAN between the switches. 10 and 20. Ethernet 5, I'm allowing the trunk and it's allowing 20. And Ethernet 6, I'm allowing 10. Alright, it's a very good way to double check your config. So leaf 1, I have to show interface trunk.
have so many good things. I can't wait for you guys to see us in them. So we went shopping. Yes, we did. And we got quite a few things. Some sexy things. Yeah, everyone needs a little like that. Oh my god. Yeah, we need to make like.
Now, default STP mode is NSOSP OS is RSVST plus. This time we'll check the STP status and we'll set priorities. So in spine 1 it shows spine tree summary. So it's showing us that it is in rapid PVST mode. Okay. Now we want to set spine 1 as spine 2, so the spine 1 will become the root bridge. So there's two set of priority values on spine 1 and spine 2. What do is a spine link tree, VLAN 10 and 20 priority will make a lower than the spine 2. So it's a 8192. What default? Default, do you remember what's default? Default is gonna be 32768. Okay, so now we set a priority on spine 1. We want to do the spine 2, spine 3. VLAN for VLAN 20, we want to do the priority is 16348A4. Okay, now let's check. So show spine 3. We change. I see that the priority changed. So let's take a look for VLAN 10. What I want to know is the VLAN 10 change it to the priority number we want. Go down and VLAN. It is because we set our priority number. Still remember it's the A192. It add up to the VLAN 10. We add a 10. It's gonna become A202. Okay, VLAN 20. So A192 plus 20 is A212. So that's how the priority is. I can see all the ports are in forwarding status. Logging to my spine 2, show spine tree. I can see the root bridge and itself. The bridge is changed also. Root bridge is my spine 1. Go back to spine 1. I'm seeing this bridge is a root. We'll confirm that root bridge is root. Okay. Now I would do a little bit for the fast convergency is gonna be setting up the STP port type. So for all these ports between the switches, these ports will be a network port. network in spanning tree, and for the switch port to the host, we want to say there's gonna be edge port. It will help STP reconverging. See, for the TCN notification, we want this to be set up. So what we want to do is to go to my spines. The spines we're gonna should say is log on to leave 2, show spanning tree. Let's take a look. I can see port 500, Ethernet port 500 is blocked, of course, and the Ethernet 4 is blocked. So this is completely blocked on leave 2. Leave Ethernet 1/4 is blocked in spanning tree. So some ports will be blacked out. The bandwidths are not being used effectively. That's spanning tree. You know, I want to talk about the network edge, right? So what are they? So spanning tree port type, what are they? We have edge, right? We have edge. That is immediately transition to forwarding states without going through the blocking or learning states. This port fast, right? So it applies to the hosts. You're connecting to hosts, and we have its network. It's considered inter-switch link. So we make sure the bridge assurance we used when require for VPC peer link. We'll talk about VPC later. And we have normal. Normal is just the default mode and is corresponding to conventional STP ports. It is okay to connect to a switch or a host using a normal type spanning tree port. So we have all these blockings. They have to make sense. They have to prevent loops. Say if this time spine 2 goes down, and because the port the 1/4 is blocked, and this BPDU is not sending anymore, the spine 1 will just block this port channel also. Alright, we have passed the L2 configuration. You have seen how this configures with basic port channel spanning tree. Now we'll talk about is L3 configuration, which is the parts between the CSR and the spines. So I will give it basic L2 network state right now. We're blocking the ports with spanning tree. Here you go. We have to configure L3 is to configure interface between the spine and the CSR. The CSR sides are already being configured. You don't have to worry. And I'll create SRVs and we'll configure HSRP. And spine 1 will be this time will be the active, and spine 2 will be standby. SRP, and we'll configure the OSPF 100. And in the end, we can track the web host in here and the ESSIs to the server 1 and server 2. Okay. Let's do some L3 interface settings. We're gonna log on to my spine 1. We'll find Ethernet 5. Okay, what we're gonna do? With no shutdown and no switch ports, so we make an L3 port. So all of these parts will be the L3. Okay. Configure the IP 10.10.30.2/24. Okay. Show IP interface brief. I can see one interface with IP. Log on to spine 2. I have two interfaces to configure, 1/5, 1/6. So, interface E15, no shut, no switch port, IP, six, no shut, no switch port, IP. Show IP interface brief. Alright, where ports are up with IPs on my spines, they are L3 interface, they are up. So take a look. We have to then configure my SVI interface. SVI interface. This is being taken care of for L3 ports. The L3 SVI. So go back to spine 1. We're going to enable the feature interface VLANs. So that will allow us to enable interface VLAN 10, no shut, IP 10.1, interface VLAN 20, no shut, 20.20.20.1. Alright, do the same thing on my spine 2. Interface VLAN 10, no shut, IP address, interface VLAN 20, no shut, IP address 10.10.20.20.20.2. Okay. Show IP interface brief. I have VLAN interface and two L3 interface. Show IP interface brief. I have two VLAN interface with IP and one L3 interface. Now we have to take care of a very good stuff. That's the HSRP. So first we're going to configure on the spine 1 and spine 2. Spine 1, I will going to enable the feature HSRP. After that, we'll have to interface the VLAN 10, and HSRP we want to is the group number 10. Okay, and give IP, and this is a VIP 10.10.10.254, and priority 120. The larger one will become active, and we're gonna prime it. Same thing on VLAN 20, HSIP, group IP is 20, IP address for VIP is 20.20.20.254, and priority will larger than 100, so we're gonna become active rather. Okay, show run interface VLAN 10, 20, configured HSRP. Go to spine 2, we'll quickly do this. Feature HSRP, enter VLAN 10, HSRP group 10, IP 10.10.10.254, and prompt. Default will be 100, so it's going to be a standby router. Interface VLAN 20, HSRP 20, IP address 20.20.20.254. Payment. That's to confirm the status. Show HSRP brief. We have show a little bit multiple time, and I'm seeing spine 1 is becoming active, confirmed, right? And go to spine 2, show HSRP brief, confirmed. Spine 2 becomes standby router for HSRP. So the HSRP part is done, and now we're going to take care of the OSPF. Okay, OSPF. Similarly, we're going to give a feature OSPF, and then you see the warning and just ignore it, and we'll say router OSPF 100 question mark. None. Okay. We're gonna create a loopback interface 0 IP 191.32. This is gonna become my root ID. Interface is now 1/5. IP router OSPF 100 area 0. Interface VLAN 10. Same thing. And also IP OSPF passive interface. I don't want to send out OSPF updates ASU to my host. Very important. VLAN 20. Also passive. Alright. Show IP OSPF neighbor. Have a neighbor. Now, spine 2. Confirm all this OSPF routes, whatever, later. Same thing, you can ignore it. Router OSPF 100. Interface loopback 0. IP address 2.2.2.32. Okay. Interface Ethernet to 6. IP OSPF. IP router OSPF 100 area 0. Interface VLAN 10. Same thing, put it in area 0. IP OSPF passive interface. Remember, interface 20. Same thing. Same thing. All right. Now we have put this interface, this interface, this interface, and VLAN 10, 20, VLAN 10, and 20. They're all in OSPF. They are advertised, and in is area 0. I will confirm neighbor is in full status, and it's DR, and show IP OSPF neighbor. On the spine 2, we have seen the 2 neighbor, which is the CSI1, CSI2. Let's confirm the routes. Spine 1, show IP routes OSPF 100. Let's see the routes. Do I have all the routes? I have four routes: 20, 40, 50, 60, 20, 30, 40, 60. Yes, I receive all routes. 60. That's right. Spine 2. Let's confirm. Show IP routes, OSPF. And have routes. I want to do a communication test. Or log on to my web server, and I want to pin. I want to pin to the servers. Server 1 and my server 2. Server 1, I don't want my ping my server 2. Let's do it. Log on to my web server. Let's ping 20.20.20.20. Can ping it, no problem. Let's ping my server 2. Server 2 is this IP. 50. Yes. I can ping all of them. Ping is okay. Let's take a look. So far, I taken care of the layer 2. I taken care of layer 3. The ping are okay to server. The next setup is the VPC. VPC will do a few things. We'll change STP priority, and we'll create a VPC domain and keep a live link with VPC. We'll have a domain. And keep it live. And we'll have to configure is the peer link. I'll configure OSPF, only the spine in this time, and also we'll have to check my server for the ping for the web host, and there's a port channel here. VPC is also VPC, so VPC here, and it's back to back. So we'll talk about what is VPC. Say you have non-VPC environment, switch, and switch. Let's connect them like this. Normally in a non-VPC is STP, and this port will be blocked. It's a blocking, right? And in VPC, we'll have the same setup, 3 routers. We connect them also like this, like a loop. Okay, but this server will become a VPC domain. There's a peer link, there's peer link between them, and from the image interface, there's gonna be a peer link. Okay, and we can make a port channel on this switch, right? So there's nothing, ports will be wasted. Nothing like STP. So VPC is a technology that configures the L2 port channel between 2 Nexus devices. It appears logically as a one switch, one single Nexus to other device, which offers various benefits such as effective bandwidth utilization and improved the fault tolerance. Pulse goes down, still goes uplink. So this setup, unlike the stacking, unlike VSS, if you know Catalyst 4000, which are familiar from Catalyst. So VPC has a major feature that each Nexus operates independently. What I mean is, like VSS, there's two switch. There's only configuration you have to be done on the one switch. Okay, that's the principle of VSS. But VPC, there's all switch, independent switch, independent switch. It's the same thing with the stacking. So I'll make some space here. We'll talk about what is APC again, what it consists of. So we have like say VPC device. Between them, we're gonna to have is is a peer link, and we have the keep alive link, and of course there's the management interface. We could do use the peer keep alive link through the management interface also. Then that's the switch with a port channel. So first we'll have a VPC device. What's VPC device? VPC device is just switch, Nexus switch itself, configured with VPC, and we have this whole thing. We call it is the VPC domain. This is a domain. This is a group of Nexus switch that configure VPC, and VPC will have a domain ID. Domain ID, it is defined and it must be unique for each group. And what is the peer keep alive link? The peer keep alive link. What is this? It is an interface that performs the mutual active monitoring between the VPC. So it spies on each other. So it's IP level communication. So it's required on the peer keep alive link. This is so it's recommended we configure on the management interface for the peer keep alive link. Configure on the management interface is recommended, and it will be. And we have another link. It's the peer link. What is peer link? What's a peer link? The peer link is used for information synchronize between the VPC device for the actual data. It's gonna be actual data communication, and it's recommended you can use a 10 gig. You use a 10 gig, and it's L2 port channel, or you can use a trunk, and it's gonna be like that. And we'll have a VPC member ports. Member ports, this port and this port, there's all gonna be member ports of VPC. Okay, there's gonna be LACP. You can without protocol, which is a mode on. It's also supported. It can be used as a L2 interface also. Okay. Take a look here. So we're gonna check the spine 1 and spine 2 spanning tree. Priority becomes 10, priority becomes 20. Also, here shows spanning tree. Becomes 10 and 20. For VLAN 10 and 20. Alright, we have to configure VPC domain and keep alive. First feature VPC. And VPC domain 1 is gonna be unique, right? Unique domain ID. Okay. And again, it tells you you have to make sure to change the spanning tree bridge priority as recommended guidelines. Okay. Rule 1 priority. It is 1000. So smaller is gonna become a primary. Okay, we use 1000. And peer keep alive destination peer keep alive is gonna use for monitoring. Okay, peer keep alive will use management interface. SPI2. We're gonna use management as our VIF. Next, we're gonna say peer gateway, peer switch, IP ARP, sync, auto recovery. Smaller firster, what we configure? Show around VPC. We configure smaller priority. It's gonna be primary. We configure the peer keep alive via management interface, and we have source, sender, and receiver. All right, let's get this down on SPI2 VPC. VPC domain 1 role priority 2000. We want to become secondary, and peer keep alive link destination with monitoring on SPI1 source itself. Okay, peer gateway, peer switch, IP ARP, synchronize, auto discovery, showroom, VPC. This is all I have configured on SPI2. Okay, domain, peer link, keep alive link, all configured for this VPC. Now I have to configure back-to-back VPC, which is on the leaf 1 and leaf 2. We configure VPC this part, and we configure this part. It's back to back. Okay, go to leaf 1. Still a feature VPC. VPC domain 2 rule priority 1000 peer keep alive destination peer switch auto discovery show run VPC. Here's all I configured. We don't have a configure like compared to SPI1. We don't have peer gateway, right? What exactly is a peer gateway? So the peer gateway is a VPC feature, allows the VPC peer devices to act as a gateway for traffic addressed to the MAC address of their peers. So let's say wherever there's a SVI, whereas SVI, so we have SVI, this will be a peer gateway. Okay. Now log on to leaf 2. Let's get downward left. Feature VPC domain 2 role priority 2000 here keep alive, so say destination peer switch, auto discovery. So run VPC. Okay. All right. So let's check all this VPC configuration. Spine 1, spine 2, leaf 1, leaf 2. Take a look at spine 1. Show VPC peer keep alive. So it tells me VPC peer keep alive status. Peer is alive. Okay, that's good. So VPC peer keep alive. Peer is alive. Now we have to find out and make sure the port channel 500 is a peer link for synchronization, right? Peer link. Now, one more thing to do. Interface. Go on to spine 1. Interface. Port channel 500. VPC peer link. Next. Interface. Port channel 500. VPC peer link. Same thing on leaf. Interface port channel 500 peer VPC peer keep alive. Interface port channel 500 VPC peer keep alive. Peer link. It's a peer link. I'm sorry. Wrongly speak is peer link. So we'll configure everything and VPC brief on spine 1. I will do confirm the peer link status. Showing here, peer link on port channel 500 is up. Spine 2, show VPC brief. It's also up for the peer link. Confirming my leaves. Show VPC brief. 500 peer link up. Show VPC brief. Same thing, 500 up. So this time VPC created domain, peer link, peer keep alive. They all created. This time to define the VPC member ports. Member ports on the spines we have 1/3, 1/4, and on the leaves also 1/3, 1/4, 1/3, 1/4. For now, we also want them to become a port channel. Port channel. That means 3 and 4 will become port channel. Then there's the back to back VPC. Okay, let's do it. Spine 1, interface, Ethernet 1/3, 4, channel group 1, mode active. Interface, port channel 1, VPC 1. Okay, spine 2, interface, three and 4, channel group 1, mode active. Interface, port channel 1, VPC 1. Okay, let's log on to leaf 1. Interface 1, 3, 4. Channel group 1, mode active. Interface port channel 1, VPC 1. Okay, leaf 2, if it's E13, 3 to 4, channel group, 1 mode active. Interface port channel 1 VPC1. After that, we have other member ports. To the servers, we have this port 1/6 on leaf 1 and 1/6 for the leaf 2. Log on to leaf 1, interface E16, channel group 2 mode active. We're going to interface port channel 2 and make sure this VPC we want a 2. We only have one VPC, right? To spanning tree port type edge trunk. Okay, so run int E16. So run int port channel 2. VPC2 is right here. Same thing. Leaf 2, interface E16, channel group 2 node active. Interface port channel 2, VPC2, spanning tree. Spanning tree, port, type, edge, trunk. Show run interface E16. Show run interface port channel 2. Now go to my spine 1. Show VPC brief. There you go. We find out the one port channel is up and active VLAN on 10 and 20. Spine 2, show VPC brief. I can see my port channel 1 is up. Go to my leaf 1, show VPC brief. I see the members, port 1 and port 2. Port channel 2, it is my server 3 site port channel, and port channel 1 is my 2 port channel actually. 2 port channel 1, back to back port channel 2 spines is up. Here you go, spine 2, leaf 2 shows VPC brief. We have here back to back port channel 1, port channel 2 also up. Go to spines, spine 1, want to take a look at the spanning tree. Show spanning tree. The spanning tree is showing me P2P on the VPC and a peer link on VPC. VLAN 2, VLAN 20 also here, same thing. So that's saying behind the VPC, spanning tree is fail safe, and we'll make sure it is working because it's P2P. Okay, show spanning tree. Same thing. To my leaf, show spanning tree. Take a look at forwarding. Leaf size all forwarding. It's all forwarding. Okay, it's all forwarding status. Nothing is blocking. Show spanning tree. Same thing. Forwarding, forwarding, forwarding. We'll do some testing on the leaf, on this web server. We're gonna ping to EXSI server 1 and server 2, and we tested that, but we change to VPC. We have to test again to the server 3. Also, we're going to try that, which actually goes to like this. Okay. Still, web host, we're gonna ping server 1, server 2, and ping the server 3. Here you go. They are all okay. Now we'll talk about a few features you see in the VPC. So show run VPC. We'll talk about what is peer switch, what is the peer gateway, what is the auto recovery, and what is the up synchronize. Now, what is a peer gateway in VPC? So there is a function that forwards the traffic to real MAC or VPC peer device on both VPC devices. In the same way, the traffic goes addressed to the virtual MAC of a HSRP. So this gives up the no forwarding to the real switch holding the real MAC address. We still can forward locally to the destination. And there's a other feature I want to talk about is it's the peer 3 layer 3 peer router. It's joined with the feature I just talked about is the peer gateway. When they're trying to forward, right, we want to use their locally forwarding, but sometimes like without a peer gateway, right? Without peer gateway, if your route protocol sometimes set as TTL1, some weird things you have on your OSPF to make sure the TTL has to be 1, then when there's a forward to the secondary, there will be we decrease 1 hop. Then there's a TTL 0, and the packet will be dropped, and your neighbor cannot be formed. That comes to the peer router. With peer router, we don't decrease the TTL, so the peer router is gonna be applied, and the peer gateway applied. The packet, your neighbor, will also be formed to the SVI's interface. This is what talk about when we want to change the priority or to the same on the VPC peer switch. This will have to type on all the VPC domains peer switch. It is when the primary is responsible. Here, the primary is responsible to process and calculate the STP BPDU. If it fails to occur on primary, a topology change will happen. So you know the TCN packets. So PCN frame will be sent out by the entire spanning tree domain. So we apply this peer switch. The primary and secondary all have the same priority, so the BPDU processing will be performed on the both VPC devices. So this requires making STP route bridge in the entire VPC domain, and topology change can be prevented when a primary fails. And STP priority will be on both peers switch. You must be the same. Here you go. For example, span 1, we have spanning tree set to priority 0. Let's gonna make a route. Show spanning tree. Show run spanning tree. Is always set to the same. Without this, we can do this also, because this the same. Default value. On the leaves, this always the same. And next feature we want to talk about, show around VPC, is gonna be showing us the, for example, we only use this feature in SVI process the VPC. It is IP ARP synchronize. What is IP ARP synchronize? When I have a switch and it's failed, the switch failed and recovers back, it won't show you have the up table from the MAC address to IP. A lot of them from the downstream switch. It's all here. So if I want to forward packets, it doesn't know. So when this recovers back, we use this command. This going to synchronize all the app table from the active one back to the secondary. This will only apply, it makes sense to apply SVI interface. With SF interface switches. Alright, next feature we enable everywhere. All VPC domains, all leaf and spine we enable this, is called auto recovery. So without this, if the primary goes down, primary is down, then you probably detected the secondary detected from VPC peer link, it goes down. Then that means the primary goes down. Then traffic try to forward to the secondary. The secondary stuck in suspended state, and VPC is not recovered. Traffic is not continually be forwarded. So with auto recovery feature enabled, peer link goes down. It takes time, takes 5 seconds, and hold down time 3 times. 15 seconds after, primary goes down. It knows, okay, primary goes down, and I have an SVI interface. I'm supposed to forward the traffic continuously. Okay, the next thing we'll talk about is auto recovery reload delay. It's a very unfortunate situation. Say both VPC peer switch goes down. They all go down, and only one VPC peer is recovered. Say after a while, then the right switch is recovered. When it's recovered, it cannot forward right away because it is waiting. It's waiting, right? It's waiting. The peer link it goes up. Peer keyboard link goes up. Then it's going to start forwarding. With this delay enabled, default is 240 seconds. With 240 seconds, this one is still down. This is still down. This is still down. And I'm up. After 240 seconds, peer link down, peer keyboard link down, and 240 seconds, I'm starting forwarding. I'm gonna just start forwarding. So that's the auto recovery reload delay. Next feature is called delay restore interface VLAN delay restore. So what it is? So when VPC is restored, uplink member port is delayed for a certain period of time, and member port is up after reconvergence of the routing table. So what does that mean? That is when it's recovering. VPC is recovering. We don't want to forward right away, we have to wait SVI. Let's wait the SVI to be up. SVI. We want SVI up, and we start forwarding traffic. So we have to define some milliseconds for the inter VLAN to be up, and we can start forwarding the packets. Also, remember, this also always, you use this when you have SVI on the peer switch. Last feature is VPC open ports. This is a very special situation. Imagine you have a switch firewall. We have active firewall. We have a standby firewall. So we have active or standby firewall. All right. This is fine. With active standby. In this situation, secondary switch goes down. You have active switch firewall to forward to this primary switch. That's okay. That's okay. So what is not okay is when you have a active and active situation. So what you have is active one, you have active firewall and active firewall. That becomes a problem. So because sometimes you only have one link to each firewall, you don't have VPC. Okay, you don't have VPC. So in this situation, secondary goes down. Say the secondary goes down. It only blocks what is VPC, what is in port channel. So this port channel is okay. This is lucky because there's a port channel. There's a port channel. This switch is okay. The host in here is okay. It keeps forwarding because this port channel is blocked, and peer-link is blocked. It's not gonna forward to here because it's VPC. But imagine there's open ports. There's open port. The VPC will not block it. That's saying that this keeps forwarding, right? This keeps forwarding to my secondary, which is down. And what we define is, what is open ports. We define, okay, this is open. This is open ports. We shut down this also when the secondary goes down. The member ports and open ports will also be suspended.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below.